Well, first off, we'd like to welcome you all to our presentation. Today we'll be covering and discussing our project, which is the Renewable Energy Vehicle. Our team members are Mario Aranega, Alonso, and myself, Marcos Vila. Now, before we begin, we would like to thank our sponsor, Joe Oriol from Bullseye Powder Coating, which has graciously sponsored and funded our senior design project. Without his help, our project would not be where it is right now. Now, this is a brief project outline of what we'll be covering today. We'll begin with the problem statement, team motivation, background, and then we'll move on to our project overview and design specifications, then timeline and division of work, and finally the global impact of our project would take on over the world. So to begin with, throughout our research, we've seen the use of small gas engines to power regular transportation throughout developing countries, as well as the Middle East and some places in Asia. Now, the main reason for its use is because they're readily available parts, they're mass manufactured, and as well as their cost is relatively low because of the mass manufacture. Now, these are some of the pros. Some of the cons are that they have low reliability because they regularly do not maintain them, and they have low efficiency. Now, our project goal, the main focus, is to replace this gas engine with a more efficient and reliable electric propulsion system while implementing renewable energy sources and keeping this power source user-friendly. Now, our motivation comes from being part of clubs here at FIU, such as the Society of Automotive Engineers, and being able to apply our work, knowledge, skills, and abilities throughout our careers as FIU students. Now, we would also like to develop a more versatile propulsion and power source for developing countries, as aforementioned, as well as reduce our overall carbon footprint and reduce our dependency on fossil fuel engines. Now, on to Mario with the literature.
So, as mentioned, we've been doing extensive research to what technology we're going to be implementing on our project, and this goes along from solar cells to the batteries and propulsion motors and the energy recovery systems. We've even looked into previous competitions, such as the Shell Eco Marathon, which is something along the lines of what we were doing, and we've looked at commercial vehicles, which Toyota is trying to produce solar cell Prius. Now, when talking about solar cells, the two main focuses that we were looking into are mono and polycrystalline, and we looked at both the efficiency and the cost per the units, and when considering our design. And what was most applicable to our project in terms of energy recovery was regenerative braking, which will be covered in a couple minutes. Now, in terms of motorizing the vehicle, we looked at the different types of motors, both AC and DC, at weight, cost, efficiency, reliability, maintenance, and we went with choosing a DC motor simply because it is a simpler implementation and a cheaper drive system for our application. And when considering batteries, we looked into two main types, lithium iron and sealed lead acid. And right here we see that we have versatility. We want to make the power source of this vehicle be removable and be able to maybe power a small appliance at the house or something along those lines, not just limited to the vehicle. And we have some of the standards that we would need to meet for our project right on the screen. And with that, I'll move it over to Marcos Alonso.
For our project, we are basing our design off a 3/4 scale vehicle, which was provided by our sponsor. This vehicle will be used as our base of design, and to implement on this vehicle, we'll be implementing a propulsion system that is both energy efficient and reliable, while keeping in mind that this system will weigh less than 40 pounds. Another goal of our design is to to provide a compact unit which can be used for other sources of power as well, such as powering a house, some lighting, so on and so forth. As you can see here, you can see the vehicle on It's been wrapped to protect the color, the paint of the car essentially. And here you can see the current engine that it has mounted within its engine bay. And here you can see the building envelope in which we're designing our system in. Here you see it with the body, and here you see it without the body. For our design, we will be looking into and implementing energy harvesting systems such as regenerative braking and solar panels, while keeping in mind safety. To tie all these systems together, we'll be using a smart dashboard which will control and monitor all these separate subsystems, such as, and even display, such as speed and solar energy collected, just to name a few things that it will display. For our first design, we'll be using these batteries here, which each are 3.2 volts and 40 amps, and when connected in series, will generate estimated about 480 watts of power. Above it, you can see the first iteration of our solar panel array, and here you can see that the solar cells are folded on top of each other, similar into a book. With this configuration, we are estimating to be able to harvest about 100 watts of power at its peak performance. For our second design, it's very similar to our first design, with the exception of the solar panel configuration and the types of batteries and the number of batteries. Here we have the second configuration of the solar panels, which all the solar cells are folded onto each other, similar to an accordion. With this design, we can fit more solar cells compared to the other one in the same footprint, more or less. So we're estimating for this configuration to be able to harvest about 200 watts of power. And the batteries remain the same amount of power that they can generate or they can put out, but the only difference is the type and the size. Back to Mario with the next slide.
When we're thinking of our design, we're thinking of a global aspect, and we want to be able to provide an efficient and affordable model and a means of transportation to these developing countries that are in need of a system similar to this. We are making it as user-friendly as possible, simply so that it is not a big transition or a big change in what they're using now to what we're going to be providing, as well as being able to provide manuals in different languages, simply if there's any troubleshooting issues, it'd be easily resolved. We also have considered using all standard parts, whether it be fasteners, wires, simply readily available materials that do not need to be outsourced or go through a big trouble to find these parts. And throughout the whole manufacturing and prototyping process, we'll be doing it at a local high school, simply to raise the global awareness throughout our community. And here we see the projected schedule for our entire project. This covers both this semester and the upcoming semester. And these are, I do say projected simply because some of these dates may start either sooner or later, depending on, just to meet the deadline of our project. And we have a very brief overview of the responsibilities of each of our team members.
Now, to conclude our presentation, some of the next steps that we'll be taking in the next couple of months to continue with our research and our project will be design and stress test the portable assembly. As you can see throughout our presentation, Marcus Alonso presented our main design components, and we will be going through the design phase of the portable assembly, as aforementioned, with our sponsor to more thoroughly suit his vehicle. Now, we will finalize the cost analysis as well as manufacturing a prototype and start comparing and data collection, and I said before, comparing the old system, the gas-powered system, to our new current system, and kind of come up with a conclusion of how well our efficiency compares and performance compares to the old system. And with that, we would like to conclude our presentation, and we'll take any questions.
Good morning. In your project, you talked about reliability and efficiency. How are you going to measure both of those?
Well, for the engine, we're going to be taking into consideration the distance traveled and the amount of time that the batteries can hold a charge. And compare how much each system takes to completely either run out of gas or run out of charge. In the case of the renewable energy vehicle, since we have solar panels, the idea would be to deploy the solar panel array to charge off of the sun. Now, in the case of a slightly cloudy situation, you still may be able to get some charge and still continue to move forward. So that's essentially how we're going to be comparing the engine compared to our system.
Reliability?
For reliability, we are looking into how to manufacture and make the parts readily available so that they don't, and also design them in such a manner that they don't fail as easily as in, let's say, smaller engines. Sometimes these small engines, when they're manufacturing them, they're cranking them out by the ton, for example, and they don't really take into consideration certain tolerances, things like that, and certain defects that may cause a failure down the road. And it's essentially just a component selection is what we're going to be looking at.
I know from a fact I've used these gas-powered engines at the house, and either the carburetor clogs up or you have troubleshooting down the road with leaks or whatever the case may be. And with a system like this, maintenance for it or repairs would be much more cost efficient and a lot quicker.
Okay, let me ask you another question. Your second design iteration said 200 watt solar. How was that calculated? Was that over time?
Well, it's kind of to piggyback off of that. We looked at the power output of each cell. So each cell provides about, depending on the efficiency of the one that we select, they're normally between 4 or 5 watts each cell. So we put them in series.
5 watts at a time, at any given time?
Well,
peak power
on how,
or
peak power. So peak power output is at 5 watts. Anywhere between 5 and 6 watts is what they're rated. So at any given time, they can either provide the power within that range. So putting them in series gives us a total about, as he spoke, about 100 watts. Now, the second design obviously has more solar cells, therefore increasing the surface area and increasing the power generation of the cell.
Okay, but you're talking about efficiency as being distance traveled. Have you done any calculations to determine whether your design can meet the required need of the vehicle?
Well, one of the things that we're taking into consideration is, and we've actually been trying to do is run the engine to begin with capped off like its full amount of fuel, and trying to run it down doing different tests such as at full acceleration to see how long it takes to drain the fuel. Taking it through different RPM ranges, seeing the miles per gallon, so to speak, and then the electrical system. When something that we were discussing with our sponsor to kind of measure the efficiency is, as he mentioned, was one is distance traveled, but as well as how long does it take for the battery to kind of drain, and depending on its usage as well.
Okay, and my last question, are you going to limit the power or the RPMs on the engine?
On the motor itself? Well,
because
everything
you got a
will be
requirement that says speed of 15 miles an hour.
That's an achievable speed. So depending on the gear ratio that we select and the stress analysis, that because if we put too large of a gear, it can cause the axle on the motor to kind of have a lot of stress and bend or break.
So max speed will be 15 miles an hour?
Well, our achievable, our goal will be 15 or more. So that's our minimum, so to speak. So that's our main goal, to achieve a speed of 15 miles an hour. Right now, I believe the maximum speed of the current vehicle is around 8. So 15 is a decent goal to achieve because of the fact that we're actually reducing the weight of the vehicle itself with our system. But not only that, if we play around with the gear ratios, in the future we will be able to kind of optimize for the kind of required application that the vehicle will be used in. So.
And sorry, to piggyback off what he said, Yes, it will be controlled with the smart dashboard. The smart dashboard will be controlling the DC motor and how fast or slow it accelerates. So yes, 50 miles an hour is our minimum, but depending on how much we limit the system to, we can possibly go a little bit faster. But we're just capping it at 15 for safety's sake, since this is a very small scale vehicle, where more than likely it'll be children who will be playing with it and driving it around. And even then, that limit can even be dropped significantly lower to, of course, maintain safety. So that the child does not accidentally, accelerate past and that can cause an accident. So for this case, we're using 50 miles an hour as a minimum, but it can even be dropped even lower for safety's sake, just by changing a setting within the smart dashboard.
The application you're trying to achieve is to enable a new vehicle, to manufacture a new vehicle, or to have your system be implemented into current vehicles?
Well, the main goal is to have our system replace the current system in the vehicle. Now, we call it a renewable energy vehicle because the system is inside a vehicle, whether it is a motorcycle, an actual car itself. And what we're hoping is that essentially it can be scaled up or scaled down depending on its application. But in the end, it will be inside a vehicle as well as being portable. So it could serve as a power source to a power hub to power different appliances and things of that matter.
So there's already similar applications in the industry.
Well, there's similar components.
What revolutionary or what new thing are you bringing to the table? Is it lower costs? Is it an easier manufacturing?
What we're trying to do is essentially bring a lower cost and more affordable energy system or energy proportion system to developing countries, as we said in our presentation, in order to kind of make it more user-friendly, but not only that, provide it to more people, not necessarily the ones that can afford it, but the ones are that don't necessarily have that much income, so to speak, in developing countries. They could still afford a system to power things like daily lives.
My last question is there a reason why you're not choosing to focus on a specific industry, like the automotive, but you widen your approach to household, automotive? You just mentioned motorcycles.
Right.
So is there a reason why you're not just picking one and trying to enhance that particular application rather than broaden your scope?
That's a good question. One of the things that we were kind of discussing is that if we focus just on one use, then there are a lot of systems out there that can actually be implemented into, for example, an automotive vehicle. Companies like EU West has been doing it for years at a reasonable price. There are systems that you can integrate into a bike. There are systems that can, like power generators, that can generate power for a house. But we're kind of trying to combine all of those into one system that can suffice and be applicable to many different kind of applications, not just one.
Right, but how are you gonna power a house with a brake generating?
Well, not necessarily a house.
Or an
We're talking
appliance.
applications.
Right. So I'm just trying to I'm trying to not issue a question, but more guide you that your system might be you might use your time better if you choose a particular focus rather than try to make it solve all the problem system, because on your poster and on your presentation you focused a lot of your attention into your braking system, right? But when you move that into a household application, you might only be able to use a solar power or some sort of other renewable energy that is applicable to a household, but you won't be able to use that system.
Right.
So now you've put time and effort and research into a component that is no longer usable in a different application. So that's just more of a suggestion than anything.
Well, one of the things that, just to kind of reiterate, one of the things that we were considering was using the regenerative braking. We're still not decided whether to use it in our application or whether it's worth it. So.
It's also, and I bring it up is because it's going to make it harder on yourself for the validation process.
Okay.
Right? Your validation, you're showing here is you're using a car to show proof of concept. So now if you also try to bring in household or appliances into that equation, then you're also going to have to validate that as well.
Okay.
It might bring in a lot of other requirements, sort of as fire protection. You're using batteries, and lithium is not a very good. It's not very popular right now for fire hazards. So I would just consider taking a single approach and trying to master that project rather than spread yourselves thin.
That is a good suggestion, actually. And the title of your project, actually, from the beginning, always was about vehicles.
Right.
So this other application, I think, is kind of thrown into it, like towards the end, probably. Which, in general, in principle, yes, this technology may be applied to different areas, but the way you're constructing it is really not directly applicable, because I mean the vehicle, like a car and a bicycle type, motorcycles, home, energy requirements are different too. You can't really make it just one size that fit them all. So, so the comments we received are right on, actually. So it's probably better you concentrate on vehicle only. But in general, yes, by slight modification in the future, that technology may be applied in other fields as well. That's probably where I'm sitting. Any other comments?
I just have
Yes.
one last comment.
Sure.
The whole intent of this is to make sure we see your engineering skills, what you've learned in school. So I'm not looking for bought this, plugged them together the way they were designed to be plugged together. I'm looking for your ability to use your engineering skills to put something unique and generate an output that's useful. So just be careful when you do this to make sure that at the end of the day, you can do some of this, but at the end of the day, you have to demonstrate to us that you've learned something in school and that you've got engineering skills.